you, Daryl. Yeah, so again, I'm Tom Talpe. I'm an architect in the file server team, responsible for the SMB family protocol documentation. This is a talk that I gave a little over a month ago at Samba XP, and I thought it would be valuable to others, so I'm glad to be able to present it here today. I'm going to go kind of quickly. It's just, I think it's about a half an hour, and if anybody has any questions, feel free to interrupt. Hopefully we'll have a little bit of time for some questions at the end if there are any. So the outline of the talk is the basic overview of the file sharing document set. I want to go into how we manage change in the document set. It's a very large set, as you'll see, and it's subject to a lot of change, and the management of that change is actually pretty interesting and pretty important to the reader because of the way the documents are published. Next, I want to talk a little bit to the understanding and the use of the documents. The template of the documents is a little bit strange to some people. It doesn't look like a normal standards document, and there's a couple of good reasons for that. So, but a couple of simple rules really help your understanding of them and how you use them, and I hope they are useful to you. And then finally, just a quick look ahead into the future of the doc set and where you'll see it going in the not-too-distant future. So everybody's probably familiar with this one. The slides advancing, no problem there, Darryl?
All is well.
All is well, excellent. So you've probably seen this page. This is the top entry level of the Microsoft Open Specifications page that you can reach from that URL, microsoft.com/protocols. And that button right there in the middle of the right-hand side, Documentation Library, will drill down to the Windows protocols. And in turn, you'll see a couple of specific programs in the Windows protocols. And these programs are sort of document sets in this context. You can think of them as mapping to a set of documents and a set of protocols. There's MCPP, which is the US-driven version of it, called the Windows Communication Protocols. These are client-to-server protocols and probably the most interesting interoperability ones from most people's perspective. And the second set, WSPP, is the European-driven one, which are Windows Server protocols. These are primarily server-to-server protocols. Most of the file sharing protocols that we're going to talk about in this presentation are in both of these. There are a couple that are only in WSPP, WSPP, but they're fairly minor, the file replication. The really interesting ones, the SMB protocols, the sort of big protocols, are all in both programs. And there's also some new programs appearing. You see that middle tab in the center with that arrow from the left. MIP, M-I-P-P, the Microsoft Interoperability Protocols program, I hope I got that right, is a new program. And over time, you'll see MCPP and WSPP kind of merge into one MIP program. That's our hope. But for the moment, regulatory processes require us to have multiple programs. So let's take a quick look at the SMB document family. These protocols here in this table are largely what I consider and what most people consider to be the SMB family. They're not all SMB, server message block protocols, but they work in tandem with that family, and they are very highly integrated in that family in the Windows implementation. Other implementations have chosen different sets, and they integrate them differently, but this is how Windows treats them and how we document them. So at the top are really the core SMB. You can see that little annotation over at the right. The 6 protocols, CIFS, SMB, and SMB2 are the main file sharing protocols. DFSC is the DFS helper, the namespace referral protocol. FSCC are basically constants for the file system control codes as well as the structures that those codes represent. And finally, FSA, the file system algorithms. Neil Christensen has spoken about FSA frequently at these events. This documents the behavior of NTFS within Windows. And I'll talk about how FSA is important to the forward-facing file protocols. There are about 1,765 pages in these 6 documents. A very large fraction of them are in MS SIFs. That's kind of our core protocol for the historic version of MS SMB. The others are smaller by comparison, and I'll talk about the reason for that. The second batch are other SMB related. These are helper protocols and helper document, FSSO, which are used with SMB to enable it to do its thing over the network. The server service is about management and about state management. Workstation service is about creating shares. Browse and Browse A are about discovering servers. And FSSO is an overview document which is used as kind of a key to the whole system. It doesn't define any protocols, but it talks to how the protocols work together. Gives you scenarios and how the protocols work. I believe we're going to talk about FASOD a little while after this presentation. A couple of old obsolete ones, MS Mail and MS Wrap. These are still supported, but they are largely legacy protocols. They're there to support earlier clients and legacy clients. And at the bottom are the other things in the family. DFSNM, the Namespace Management Protocol, FRS and FRS2, otherwise known as DFSR, are file replication. They're used in Active Directory deployments and replicated server deployments. RDC is an algorithm used by FRS1 and FRS2. DFSRH and GPFR are additional group policy and helper protocols for managing these deployments. In total, there are about 19 documents today and about 3,300 pages. So it's a fairly large section of the corpus. It's, I forget exactly how many pages are currently in the corpus. It depends on which program you read. But it's high single, low double digits percentage of the corpus. So some document relationships. MS SIFs defines the Common Internet File System Protocol as it was originally conceived by outside of Microsoft, actually, and then became a Microsoft offering. SIFs is a name which is applied in many different ways, but the way Microsoft defines it, it is only this legacy version of the SMB family. Our coverage ends at Windows NT 4. MS SMB picks up where SIFs left off, and we call it now the Server Message Block Protocol. It's also, however, a historic protocol. It's still supported by modern Windows systems, but it is not the primary choice. SMB2 is in an evolutionary way supplanting it. The document MS SMB is an extension to MS SIFs. You can't use it standalone. It only works with SIFs in your left hand and MS SMB in your right hand. MS SMB covers right up to present-day Windows. So it has all the exceptions, all the extensions, all the different behaviors that Windows has right up to the present day. And finally, MS SMB2 is the Server Message Block version 2. It's a completely new protocol, semantically similar to SMB and SIFs, but a completely new re-architected protocol that emerged at the Windows Vista Server 2008 timeframe. So MS SMB2 is the new version, if you will, of the protocol, and frankly the preferred version of the protocol. And it's covered in the document set from Windows Vista going forward. Some support protocols, these are the other three in that core SMB set. DFSC defines the DFS namespace referral protocol, which is used for resolving distributed file system paths. FSCC are the file system control codes, which are the types, the constants, and the actual definitions of the FSCTLs, if you will, the control structures themselves. These are only the ones that flow over the wire, but they are the ones that are used by SMB, SIFs, and SMB2. And finally, MSFSA, or the file system algorithms. It defines the underlying file system abstraction, and in particular, it defines the behavior of NTFS. It's a very, very important document. So I'll talk about that when I get down to how the documents are used. All these documents, all three of these are invoked by all. SIFs refers to them, and they refer to SIFs. So you can think of these documents as a very tightly bound together set of 6 documents with cross-reference. Then there's some support protocols that live outside of SMB space, which are used for management and state management. The server service has management routines. You can actually control the server. You can start it up, shut it down, things like that with server service requests. But also it has a common state, and I have some slides on that. It serves more than a protocol, in other words. It's part of the architecture of the documents and of the way we present the documents in an abstract fashion. Workstation service, WKST, about 1/3 of the document is related to SMB administration and management, so there's a small portion of text there that's interesting. Browse and Browse A work in tandem with the NetBIOS network architecture, if you will, to form a browser protocol for server discovery. Largely a legacy protocol, but still in use today. Other SMB-related, FSSO, the File Access System Overview, we'll talk about how it's being rewritten or re-architected into two pieces over time. MS Mail and MS Wrap provide legacy SMB access and administration. Replication and DFS management are all related, but not the subject of the talk today. So change. This past year, past calendar year, roughly, since roughly the time of this Plugfest last year, has seen a lot of change in these documents. The first and most important, most significant source of the change has been the intense scrutiny by the technical committee, by the regulatory process. The technical committee was created by the regulatory process as part of reviewing and overseeing the creation of these documents. The technical committee filed thousands of issues on our documents, and it was actually very good scrutiny, very good content. But it created a lot of change in the document. So if you haven't looked at it lately, you might want to look at it again. The technical committee's process actually wrapped up just last month. So the change has shifted to the other sources of input we get on these documents, which of course have always been there, but now are becoming the primary source. Formal protocol and document test process. Microsoft has a formal test process, and there are, of course, other tests that we perform in the course of developing and maintaining the protocols. Every time a defect is detected, that is a difference between what we document and what is observed. A bug is generated, and that bug is resolved. It's either discovered to be a problem in the test, but more often it's discovered to be a detail that was either missed or slightly misdocumented or had some other issue in the documentation. It's not as simple as clarity. There's quite a bit of interesting behavior here that comes out. A whole lot of details like bits used, error codes returned, things like that. A lot of change from active Plugfests and licensee feedback. We have the yearly CIFS Plugfest at SDC. We have these Microsoft-hosted Plugfests like the one that you're participating in right now. And we have licensee feedback, that is bugs from people who attempt to use these documents and who implement the protocols and discover interoperability issues. We have a constant stream of licensee feedback, all of which are very promptly addressed. And finally, there's internal review. We read these documents internally. We have a large writing team and editing team which maintains the documents, their references, their adherence to the template, etc. All these factors produce change in the document. So just an example, what happened to MS CIFS? It's the largest document in the file sharing area. It came to exist almost 2 years ago. Chris Hertel and his company Ubix created it for us. By April 2010, when we were really in the swing of publishing it and reading it, it was first published in September '09, but it gained a lot of steam by April 2010. By then it was 763 pages. Pretty substantial document, over twice as large as any of my other documents, for instance. But in the year between April 15th, 2010 and April 15th, 2011, it had grown another 21 pages to 784. It had 706 issues filed against it, approximately one issue per page. With those 706 issues had 2,660 total changes, so 3 to 4 changes per issue. 5,400 body text revisions with insertions, deletions, and moves. So there's a very substantial amount of change just in the 1 year on this one document. Not all our documents are this active, but and this, I'm not sure this was the most active document in percentage, but there was some substantial change, so you have to keep watching it. So how do you know what the change was, though? These are living documents. They're republished regularly. We don't actually revise the documents with old stable versions and new revision versions, right? We replace the documents, and the regulatory process required us to do that, and it's the process that we've adopted as a result. However, internally, the documents are stamped in Section 1 with a date and a revision number. And way down in Section 7, there's a change log. The change log is marked with the tracking number, this thing called the TDI, Technical Document Issue. And the technical document issue maps back to those sources that I mentioned on the previous page, that it can be TC, internal review, testing, et cetera, licensee, et cetera. The changelog resets with each release, though, and each release is about every 1 to 2 months. That rate may slow down in the future because people have trouble swallowing a new document every 1 to 2 months. But the changelog resets each time. So the changelog is a little bit unreliable. If you pick it up on a random date, you might have missed a change cycle. Generally speaking, use the latest document because we're always updating it. But also look at that date and revision number to get a feel for what may have changed in terms of how long the cycle has been since you saw it last. So here's just an example. In MS SIFs, the changelog on the left, that table shows the revision history back from 9/25/2009 when it was first released, all the way up to the March release, which I think it might not be the most recent. I believe this was republished in late April, possibly sometime in May. That would be version 14.0. In any event, you notice that all the revision classes are major. And this will change. Stability is coming to this document. We've completed the regulatory process of it, and we have a document which defines really the historical behavior of systems. So I expect this document to more or less level off and start to stabilize. Its change will become more stable and more reliable from revision to revision. That said, there will still be edits to it. We found a bug in it just the other day, as a matter of fact. And we have, of course, Windows behaviors to document. So you will see changes continuing. On the right is just an example of the changelog. And you can see that it has a major, minor thing. It has a TDI number down the tracking number, if applicable. And it has a change type. There are a number of template-derived change type fields over there on the right. But each one will show the section, the bug number, and a brief description of what actually was changed. So these can be very helpful to pick up quickly what might have changed in the document. So using the documents, normative statements, doubting. This is, I believe, one of the most misunderstood aspects of the document set, and one which I just want to put out to people so everybody is clear with it. Each document near the beginning states this paragraph: may, should, must, should not, must not. In all caps are used as described in RFC 2119. And all optional behaviors in the document use one of those three statements: may, should, or should not. That is absolutely true. However, it's true of Windows. We are required by our documents to describe the behavior of Windows, not of the ideal protocol, not of the behavior that we might imagine the protocol to have, not even the behavior we think the protocol should have. We're required to state what Windows does. The word must has a very special meaning that I'll make a little more clear on the next slide. But I just want to say the protocol template requires this for compliance. So you have to read these documents as if they were documenting Windows. And there's a couple of interesting results from it. The statements are not necessarily written to constrain these other implementations. If you want to do exactly what Windows does, do everything Windows does. do everything the document says. But that's not necessarily a requirement of interoperability. It needs to be thought through very carefully, and each case is different. I'll give you a couple of specifics as we go here. I also want to note that no other RFC 2119 terms are used. Some people say, what happened to recommended and optional and things like that. We just don't use them. The template simplified that statement, and we try not to use these other terms. Shouting, simplified. What do we mean when we shout? If we say must in the document, we mean Windows always does it. If we say must not, we mean Windows never does it. You can choose your own behavior, but that's what Windows behavior is. Should says that Windows does it except as noted. You'll always see a note following should, may, and should not that give the exceptions. And these are chosen carefully. But should generally means you should do it. It's a recommended behavior that Windows doesn't always get right, sometimes for historical reasons, sometimes just because things changed over time. May and should not have the opposite meaning, however. They are not suggestions that you do what Windows do. They are statements that Windows does not do it, ever, except as noted. May is the most confusing one in this way. People read may and they think they have a choice in front of them. Windows does not do it when you see may. You do have a choice, but we are telling you by the template that Windows does not do it. So bear that in mind, because may is probably the most surprising word in this list. And it's also important to beware the shouting that's not made. We sometimes don't say things. If we were to say Windows may do something without any qualifier, it would be, we can't do it because it's a non-testable assertion, right? How do we make Windows not do something, right? It's non-testable. So very often we don't state this. Sometimes Windows doesn't do things and we don't say it doesn't do things. You know what I mean? You can't prove the negative. So very often the template, to avoid confusion in the end, simply doesn't say it. So if we don't say it, you can assume that Windows doesn't do it. We're required to put in our document every bit that Windows emits on the wire. So bear that in mind. We may not say we don't do it. And occasionally, documents will give informative advice with the word can. We can't use may because that confuses people. So we use the word can. So wherever you see the word can, that's only one use. But, we might be giving you a little bit of advice there. That one's hard to pin down, but we try to be helpful when we're allowed to. So proceed with care when you see something missing from the document. It's likely that Windows doesn't do it. Should you not do it? Generally, yes, you should not do it or should do it. But occasionally, maybe not. If your implementation doesn't support it, if you understand the reason very well, or if you're avoiding a bug. Very often the reason we'll say should is because Windows has a bug, right? And it has an exception that we have to call out with should. You may want to think through the Windows bug and don't be bug compatible. It's very hard to generalize this fully, and you really need to think it through. So here's an example. Good sense. In MS SIFS 3.2.4.2.5, we have this little section called Connecting to the Share. And you'll see some color-coded words here. We have a must perform anonymous authentication. We have a should be reused. We have a may use the deprecated. And then we have a couple of musts. Good sense would say implement those musts, right? Windows does it, and just reading them, you can tell that it's important. Do it. Strongly consider implementing the shoulds, right? Reuse the connection, right? That's a should, because you'll behave like Windows does, and it's just good sense. You're saving resources on both sides. Don't implement the may unless you really mean to. If you really want to use a deprecated, basically antique RPC or SMB command, you can, and Windows will reply to it. But you may want to think about that one. Windows doesn't do it, so I guarantee you there's going to be some quirks, and you'll be blazing new ground. In the other sense, here's some nonsense. This was an interesting one. This came up late in the process when we noticed that we failed to document some server operations, NetRU's add, in the workstation service. And that workstation service had left it out for a very good reason. The reason was the client never emits this request. And there's no good reason to handle this operation remotely because it's a local-only operation. Interestingly, however, that we discovered when this bug was filed that the server did process this RPC, this request. And we were rather shocked by that, and we intend to not do it. But we had to write some very interesting text here. We basically said workstation servers, you see that second line, should not allow this method to be invoked remotely. And then we had a little exception that said, even though we do expose this call, it's intended to only be called locally, and clients will never call it. So what we've done is we've documented the RPC behavior, but we've advised you strongly not to do it. And at the bottom I say, technically we should have said must implement. And the reason for that is that Windows does this, right? So technically we say must. But we wound up saying should because we intend to fix this. And I believe it's the right advice to give you as an implementer. So read carefully. That's the advice from this. So just to wrap up some examples of change, structural changes in the document and how we changed a couple of relationships between CIFS, SMB, SMB2, and some of the support protocols like ServS. We had this concept in the original SMB documents called shared state. And the idea was that when, for instance, let's say a session was created or some protocol-specific object was created, the concept was that each protocol would be responsible for its objects, and then they would be shared with ServS for management. So ServS could somehow reach into these protocols and inspect these objects and do things to them. And it was written very much like the code was written, but it was not a very good approach for a document. It was very unmanageable in a document. We couldn't consistently cover all three protocols. Not all the protocols had the same state, right? They're different protocols. They have different state. So it didn't consistently cover in all cases. It totally violated locality and ownership. The ownership of the structure. You can't have one protocol reaching into the other protocol and changing the internal state of it, right? So the documents became buggy as heck. They were just very, very hard to manage because every little tweak in one protocol rippled through three other documents for a total of 4 documents that had to be changed. So this is just a picture of how it used to look. Basically, there were 3 protocols, each with their own set of states and each with their own set of objects within that state. And then ServS would reach into that list. So well, this is just an example of the shared state. I'm just going to skip this for simplicity. We have a new concept that we replaced this with, which we call managed state. We moved to an abstract common registry of objects. The objects are allocated and owned by the protocols and then registered with ServS. So in effect, the objects didn't move, the architecture of the documents didn't move, but the registration of these objects and the requests to manage these objects did move and move to ServS. So in effect, we still create a session, but after creating a session, we register it, as you can see in that line of pseudocode in the bullet. ID equals register session. And then that register happens in ServS, where ServS creates an ID. Abstractly, you can think of it as the address of the object, and puts it in a list, creates this ID. The management, query, destroy, etc., all happens by ID instead of by some sort of abstract session. There's a concrete identifier. Think of it like the address of the object. It's unique on the server or client. And so what we have now is this state over to the right of IDs, which is very abstract, which is managed only by ServS, and which is requested to be changed by 4 sources. all the protocols, of course, as they create them, destroy them, do things to them, and management APIs, which want to query them and control them. So it's a very different architecture, but the documents are, in many ways, very similar. But it's an interesting change source to look for in our work. This slide will give you some examples. It's probably not that important to drill down into it. The second structural piece that I want to talk about, though, is MSFSA. FSA is quite possibly your most, as a file system, file server developer, it's quite possibly your most useful document for understanding the Windows file system behaviors which underlie the file sharing services. And you can see this paragraph from the introduction of FSA that says it defines an abstract model for how an object store, that is a file system, can be implemented to support these protocols. Mainly, what FSA does with respect to SMB is it provides error codes and algorithms. Basically, what can go wrong, what errors will be returned, because SMB doesn't define many of these errors. These are local errors. The error codes are key to aligning an interoperable implementation with SMB as the lingua franca, the protocol that you use. Second, the algorithms, and some of them are really very key to SMB operations, and which are in many ways unique to Windows, but obviously have been implemented in other operating systems. These were core Windows features or concepts which were exported and exposed by SMB. Op locks and leases, for instance. Locking and lock conflicts, the behavior of locks is very different from Windows to POSIX systems. Change notify semantics. What does it mean to signal a change notify? What actually has to happen to signal a change notify? What's a wildcard? How do you match? How do you check access? All these algorithms are defined in FSA in very good abstract detail. So I would encourage you to go look at them. And here's just an example of the use of FSA, but it shows you that the references to FSA live primarily in behavior notes, but occasionally in the body of the text where it refers to the conditions under which things happen. These are technically behaviors, but they are close enough to the behavior of the protocol that we chose to put the reference in the body of the text. So in general, you'll see one of these two forms. You'll either see a general reference to FSA to find conditions, behaviors, algorithms, etc., or you'll find a very specific reference to FSA where we talk about how object store parameters map to SMB2 parameters. And typically one will be in the body, one will be in a behavior note. So this is just a quick key to figuring out where to look. And finally, some next steps. You'll see change continue in these documents, in these 19 documents. You'll see continued refinements and changes from peer review, real-world testing, and Plugfest. I expect stuff to come out of the work you're doing there this week. Formal protocol testing, which continues in earnest within Microsoft and elsewhere. And finally, new protocol features. We are revising these protocols. SMB2 in particular will move on, and you'll see new protocol features in here. And you'll see this new content very carefully defined and the behaviors described in these documents. So the process will continue in perpetuity, in fact. And your feedback and participation is key. The peer review, the real-world testing are absolutely key to the interoperability success of these documents. And I greatly look forward to your continued participation and feedback into these things. So basically that's it. I hope you've enjoyed the tour. Happy to have questions.
Questions? I see any hands yet? Steve? Oh, shaking his head. No question from Steve.
Okay. Steve has seen this one before, so.
That's true. Anyone else?
Oh, okay. Clarification on the serve and protocols going into serve service.
I could hear most of that question. I think it was a question of whether there was any related code change in tandem with the document change.
The service.
Actually, no. There was no code change at all. It was we attempted to better describe the way the code and protocols behaved, and discovered we needed to change the document. It's abstract. It's more abstract than it used to be, but we believe that it came out with greater clarity and greater manageability, greater separation, if you will, better abstraction between the functional components. The code didn't change, the behavior didn't change, no interoperability was harmed in the course of re-architecting the state of the documents. But it was a pretty radical change. It's kind of surprising to think back on how many changes we made to implement it, and you know, how it altered the document. It was actually a surprise, but we have a much better and I think more useful document as a result.
Other questions? Great. Well, as Tom mentioned, the FSSO document is evolving into FSAOD and FSMOD. I believe I got those right. And Neil is about to provide a presentation to give you some references regarding those.